Hello and welcome to Algebra 2 Lesson 50. In this video, we're going to learn about adding and subtracting rational expressions. So again, we've come across another lesson that we talked about back in Algebra 1. So we should at this point have a fair understanding of how to add and subtract rational expressions. If you don't, you can pick it up from this lesson. We're just going to go a little bit quicker. In Algebra 1, we had two separate lessons. We first talked about how to find the LCD for a group of rational expressions, and then we moved into a lesson where we talked about how to add and subtract rational expressions. Here we feel like you have enough understanding of this. It's just a review, so we're going to compact it into one lesson. So I have here, when we add or subtract rational expressions, we follow the same rules we learned with fractions. So essentially, when the denominators are the same, you just add the numerators and place the result over the common denominator. So if I had something like 1/4 plus, let's say 3/4, I have a common denominator of 4, so that stays the same. And I add 1 plus 3, which is 4. And then the thing you want to do whenever you're done is simplify. We know 4 over 4 is 1, right? So we would simplify that. Now the other scenario, the more difficult or challenging scenario, is when the denominators are different. So the first thing is you have to find the LCD, and then you have to write your fractions as equivalent fractions where the LCD is the denominator, and then you can proceed with your addition or subtraction. So if we thought about something like, let's say 5/6 plus, let's say 2/3, just to make it really easy. We know the LCD would be 6, right? Or hopefully you know that. So I would take 5/6 and I would leave it unchanged because the denominator is already the same as the LCD. For 2/3, I would perform a little trick. I would multiply it top and bottom by the number 2. 2 over 2 is the same thing as 1. If I multiply by 1, I'm not changing something's value. So if I do 2 times 2, that's 4. And it would be over 3 times 2, which is 6. So we can say this is 5/6 plus 4/6. And now I can do my addition. My denominator is the same. It's a 6. 5 plus 4 is 9. So I end up with 9/6, which of course we can reduce. 9 and 6 share a common factor of 3. So if I cancel a factor of 3 here, this would be 3. If I cancel a factor of 3 here, this would be 2. So we end up with an answer of 3/2. So those are your two scenarios when working with fractions. And it's the same exact thing you're going to come across with rational expressions. It's just much more tedious because you're working with variables. The variables have powers. There's all kinds of things that are going on. All right, so let's start out with some real easy ones, just to kind of get our brain going. So let's suppose we see x minus 4y over 6xy plus x plus 3y over 6xy. So your denominator is the same. You have 6xy and 6xy. Just like when we work with fractions, again, if the denominator is the same, keep the denominator the same. So for the answer, I'm just going to keep 6xy in the denominator. And I'm just going to add the numerators. So I would have x minus 4y. It's addition, so I'm just going to put plus and then write this, x plus 3y. I'll make this a little longer. So what would this be equal to? Well, essentially, I'm just going to combine like terms. X plus x is what? That's just 2x. And then negative 4y plus 3y would be negative y, or just put minus y. And this is over that common denominator of 6xy. Now, the last thing you always want to do, you want to see, can I simplify this further? Usually what you would do is just try to factor everything. Now, with 2x minus y, I can't really pull anything out. If I had something I'd pull out, like let's say I had a 2 here, well, I could pull a 2 out and I could cancel that with the 6. But that's not the scenario I have. I have 2x minus y over 6xy. Nothing I can do to simplify further, so this is our answer right here. All right, let's take a look at another easy one. So let's suppose we have m minus 6n over 15m squared n plus 5m minus n over 15m squared n. So again, the same denominator. So if I have a common denominator already, all I need to do, it's very, very simple. I'm just going to add the numerators. So I would have m minus 6n plus 5m minus n over that common denominator of 15m squared n. So I'm just going to combine like terms in the numerator. So m plus 5m is 6m. And then negative 6n minus n is negative 7n. And this is over, again, 15m squared n. So is there anything I can factor from the numerator here that I could cancel with the denominator? The answer to that is no. You have 6 and you have 7. Number-wise, no. Variable-wise, I have an m and then an n. So nothing I can really pull out. So this is going to be your final answer here. 6m minus 7n over 15m squared n. All right, so let's look at one final easy one, and then we'll look at some scenarios where we don't have a common denominator given to us. So we have 3x minus 3y over 8xy squared minus x plus 6y over 8xy squared. So I'm looking at this, and again, I notice that I have this common denominator of 8xy squared. So that just stays the same. I have subtraction here. So this is where you got to be real careful. I am subtracting this whole thing away. So remember, if I'm subtracting something away, I can add the opposite of it. So for the numerator, I have 3x minus 3y. Then what I'm going to do is I'm going to put minus, okay, minus, and I'm going to put inside of parentheses this x plus 6y. That's going to remind me to distribute that negative to each term, and I'm changing the sign of each term. I'm going to add the opposite of it. And this is over. We have that common denominator of 8xy squared. All right, so let's go ahead and work this out. We have 3x minus 3y. I'm going to distribute this to each term. So I can think about this as having plus a little negative 1 here. Negative 1 times x is minus x. And then negative 1 times 6y is minus 6y. And this is over. You have 8xy squared. All right, scroll down and get a little room going. All right, so the next thing I'm looking at is I have 3x minus x. That's going to give me 2x. Then I have negative 3y minus 6y. That's going to give me negative 9y. And this is over that common denominator of 8xy squared. So nothing I can do to simplify any further. I just report my answer as 2x minus 9y over 8xy squared. All right, so let's look at one where there's not a common denominator. We'll start out with something pretty simple. We have 4 over p plus 4 plus 3p over p minus 4. So before we even do this, let's just think about two fractions for a second. Let's say I had something like 1/3 plus, I don't know, let's say 2/5. To get the LCD, what do? I take the denominators and I factor them. Now, 3 and 5 are each prime numbers, so there's not really anything I can do to factor them. They're just 3 times 1 or 5 times 1. So what I want to do when I build my LCD, that's what? It's the least common multiple of these two numbers, so of 3 and 5. And so to do that, when I have my factorization, I list each prime factor. The only exception is when I have a duplicate prime factor. So if I have a prime factor that occurs in each prime factorization, I go with the largest number of repeats. Now in this case, I just have a 3 and a 5. So I would put 3 times 5, and that would give me 15. So I would convert each of these into an equivalent fraction where 15 is the denominator, and then I could do my addition. So hopefully you remember how to do that. I know for some of you it's been quite a while since you've had to do that, but it's going to be the same process here. I look at my denominators. So I have p plus 4 and I have p minus 4. So the question is, can I factor p plus 4? No, I cannot. Can I factor p minus 4? No, I cannot. So just like when I had a denominator of 3 and a denominator of 5 and I couldn't factor them, I just multiplied the two together. I'm going to do the same thing here. So the LCD is going to be what? It's going to be p plus 4 multiplied by p minus 4. And generally, we want to leave this in factored form. I know you could use FOIL here and kind of write it in a different format, but we want to leave it like this. All right, so if this is the LCD, and I have, let me kind of just drag this up here so it's out of the way. So if I put equals here, I'm going to have 4 over p plus 4. Now, the LCD is what? It's p plus 4, that quantity, times p minus 4. So in order to have a denominator of p plus 4 times p minus 4, I've got to multiply the denominator by p minus 4 and also the numerator by p minus 4. Make sure you're using parentheses here because, again, this is the quantity p minus 4. Okay, don't make that mistake of saying, okay, I've got 4p minus 4 like that. That's wrong. Okay, you don't want to do that. Then you're going to have plus. So next you see you have 3p over you have p minus 4. And what am I missing here? Well, I'm missing the p plus 4. So let's multiply the top and the bottom by the quantity p plus 4. And let's scroll down and get a little room going. So if I do 4 times the quantity p minus 4, I'd have 4p minus 16. Then plus, you have 3p times p. That's 3p squared. Then 3p times 4 is plus 12p. And this is over. You've got p plus 4, that quantity, times p minus 4, that quantity. So if I combine like terms in the numerator, you kind of scroll down and get a little room going. I'm going to start out with 3p squared. Then next I look, I see 4p and 12p. Well, that would combine to give me 16p. And then lastly, I'd have minus 16. So then this is over. We have p plus 4 times p minus 4. So I'm not done because with these, I want to see if I can factor something. I have left this in factored form to see if I can cancel. So let's try to factor this right here into the product of two binomials. And let's see what we get. We're trying to see if we can cancel anything with the denominator. So give me two integers whose product is 3 times negative 16 or negative 48. So this would be my product I'm looking for. And we want a sum of 16. So we know we need one positive and one negative. So let's think about the factors of just positive 48. Forget about the fact that it's negative. So for 48, you've got what? You've got 1 and 48. Those are obviously too far apart. You've got 2 and 24. Those would never work. It is divisible by 3. It's 3 times 16, but those won't work. Now you could also do 4 and 12. Now it seems like 4 and 12 would work because you've got a positive 16 there. So you could say, okay, well, 4 plus 12 is 16, but you can't make the sign work with the product. If I made one of those positive and one of those negative, you will not get to that sum. So then the next thing we try, it's not divisible by 5. It is divisible by 6. It's 6 and 8. So 6 and 8. But that won't work. So after 6 and 8, we don't have any more factors. So I would say this polynomial is prime. So let me erase this. And I will say that this is prime. And because this is prime, there's nothing else I can do to simplify it. And so this is my answer. 3p squared plus 16p minus 16 over the quantity p plus 4 times the quantity p minus 4. All right, let's take a look at another kind of easy one. So we have 4 over 2n squared minus 12n plus 7n over 2. So I've got a denominator that's just a 2, and I've got a denominator that's a 2n squared minus 12n. So I can't really factor 2. It's a prime number. It's just 2. If I factored this, what could I do? Well, I could pull out a 2n. And then I would multiply that by the quantity n minus 6. So because this already has a 2, and this has a 2, when I think about my LCD, it would just have one 2 in it. So my LCD would have a 2, and then it would have the rest of this, times n, times the quantity n minus 6. So this guy right here already has all that. All I need to do is change this rational expression here. So let me, again, move this up out of the way. We'll say this equals. I'll kind of erase this real fast. So for the first guy, I'm just going to write 4 over. I'm going to write this in factored form. So 2n times the quantity n minus 6. Then plus, for this guy, I have 7n over 2. And I'm multiplying by what I'm missing. So I'm missing an n, and I'm missing the quantity n minus 6. All right, so let me put equals, and we'll just scroll down and get a little room going. We'll have 4 plus, we're multiplying 3 of these guys together. So the order isn't going to matter. I could do 7n times n first, That will give me 7n squared. So let me put 7n squared here. And then times the quantity n minus 6. And let me just do this down here. The denominator we know will be 2n times the quantity n minus 6. All right, so we'll continue. We have 4 plus, you have 7n squared times n, that's 7n cubed. And then 7n squared times negative 6 would be negative. 7 times 6 is 42. And then your n squared would come along for the ride. And this is over. We have 2n times the quantity n minus 6. So this isn't going to be something we can factor in the numerator, but I can reorder it, put that polynomial in standard form. We'll write 7n cubed minus 42n squared. Let me kind of make that a little better. And then lastly, plus 4. Then all over 2n times the quantity n minus 6. Again, I leave this in factored form in the denominator just to show that nothing is going to cancel. All right, let's look at one that's a little bit more tedious. So we have 7 over, we have 2n cubed minus 6n squared. Then we have minus 8 over n minus 3. So remember, I have this minus here, so I've got to be very, very careful. What I can do, I can put that this is plus, and then I can make this a negative 8. If I put plus, and then I change something to its opposite, meaning I multiply it by negative 1, I'm good to go. Right? That's preferable to what we normally do because students will get confused. So once I've rewritten this problem, I think about the denominators. So this is 2n cubed minus 6n squared. I could factor out a 2n squared, and I'd be left with n minus 3. And then here I just have an n minus 3. So what's common to both? They each have this n minus 3. I'm just missing the 2n squared. I'm just missing this 2n squared. So again, we come to the scenario where this first guy here is unchanged. We're just going to have 7 over. We have 2n squared times the quantity n minus 3. And that's in factored form. Then I'm going to put plus. Remember, I changed this to negative 8. So we'll have negative 8 times, what am I missing here? I'm missing 2n squared. So times 2n squared over, you would have n minus 3 times 2n squared. So I'll put 2n squared over here like this, times that quantity n minus 3. So now I have a common denominator, and so I can just go through now. So I have 7 plus negative 8 times 2n squared is negative 16n squared. And then this is over. We have 2n squared times the quantity n minus 3. So let me just reorder the terms. And we'll put negative 16n squared plus 7 over 2n squared times the quantity n minus 3. So not really anything I'm going to be able to do to simplify this any further. So we just leave our answer like this. We have negative 16n squared plus 7 over 2n squared times the quantity n minus 3. All right, now let's get into one of the more tedious problems. And you'll typically see more of these in Algebra 2 than you did in Algebra 1. So you have 6p minus 8 over 3p squared plus 20p minus 7 plus 13p minus 11 over p squared plus 6p minus 7. So I want to just start by getting a common denominator. So I'm going to factor this guy right here, and I'm going to factor this guy right here. So I know this one's easier, so let me just start with that. I know this would be p and this would be p. Two integers whose product is negative 7 and whose sum is positive 6. I could do positive 7 and negative 1. Positive 7 and negative 1. If I did 7 times negative 1, that's negative 7. 7 plus negative 1 is positive 6. So that checks out. For this guy right here, I've got a non-1 as my leading coefficient. So it's a little bit more challenging to factor. We can use reverse FOIL just to get a little practice. Let's go with 3p and p. Remember, this is a prime number, so I go with that to start. Now I need to work out my outer and my inner to where the sum is 20p and the product is negative 7. Now, it's easy because negative 7, or just 7 in general, is a prime number. So really the only possibilities are positive 1 and negative 7, or negative 1 and positive 7. So I can try different combinations. I could say, okay, if I had positive 1 and negative 7 like this, what would that give me? Well, the outer, just think about the numbers. 3 times negative 7 is negative 21. The inner, 1 times 1 would be 1. So if I sum those, I would end up with a negative 20. Well, I want a positive 20, so all I have to do is just change the signs around. Everything's in the right position. So if I make this negative and this positive, I'm going to be good to go. All right, because my outer would be 21p. 3p times 7 would be 21p. My inner would be negative p. Those would sum to be 20p. All right, so I've got my factorizations going. Now, what do they share? Well, they each share p plus 7. So that's already there. All I need to do to think about the LCD, again, everything gets listed, but what they share, or what's common to both, just gets listed once. So I would put 3p minus 1, then times p plus 7, and I've got a p plus 7 here and a p plus 7 here, so it only goes in once. You go with the largest number of repeats between any factorization. Then I've got a p minus 1. So that's my LCD. So in other words, for this first one here, I am missing the p minus 1. So I'm going to multiply 6p minus 8 times the quantity p minus 1. Then plus, over here, what am I missing? Well, I have p plus 7, I have p minus 1, I'm missing 3p minus 1. So I'm going to multiply 13p minus 11 times, again, what I'm missing, which is this 3p minus 1. Then for the denominator, we already know that's going to be the LCD. So that's 3p minus 1 times p plus 7 times p minus 1. And again, these can get quite tedious very, very quickly. So let's go ahead and use FOIL here. 6p times p is 6p squared. The outer 6p times negative 1 would be negative 6p. The inner negative 8 times p would be negative 8p. We can go ahead and combine like terms here. We know that's negative 14p. And the negative 8 times negative 1 is positive 8. Then we have plus. Over here, 13p times 3p is 39p squared. The outer 13p times negative 1 is going to be negative 13p. The inner negative 11 times 3p is minus 33p. And then the last, negative 11 times negative 1 is positive 11. All right, so what can we do to combine like terms here? Let me write this over that common denominator of 3p minus 1 times p plus 7 times p minus 1. So I have 6p squared and 39p squared. So that would give me 45p squared. Then next, I have negative 14p. I have negative 13p. That's negative 27p. And then minus another 33p, which would be negative 60p. And then lastly, I have 8 plus 11, which is 19. So this is all over. We have 3p minus 1 times p plus 7 times p minus 1. So is this guy in the numerator factorable? We think about 45 times 19. That's 855. It's a pretty big number. So I think about 855 as the product I would be looking for the two integers, but it would have to sum to negative 60. Well, this would be 5 times 171. 5 is prime. 171 is 19, which is prime, times 9. 9 is 3 times 3. So not a whole lot of factors for 855. If I played with the signs, let me just think about this for a second. If I played with the signs, could I make it work? The answer to that is no. So let's just quickly go through these factors real quick so you can see. The first thing would be 1 in 855. We really don't need to list that, but we will anyway. We know those are too far apart, so this will never work. So let me just line that out. The next thing you would come across, just look at your factor tree. You'd have a 3. So 3 times what? Well, what's left? 3 times 19 times 5, which is 285. Again, those are way too far apart, so even playing with the signs, I'd never get anywhere. So the next thing we would come across, we see we have a 5, so I could put 5, and then what? Well, it would be 19 times 3 times 3, which is 171. But again, I can't play with the signs and make that work. So then I would go to 3 times 3 or 9 times what? You'd have 19 times 5 or 95. But again, that's not going to work. I can't play with the signs and make that get to negative 60. So next I think about 5 times 3 or 15. 15 and what? We'd have 19 times 3 or 57. Again, those aren't going to work, so you can line that out. Then the last thing you could try is 19 times 45. So 19 and 45, and those obviously wouldn't work. So I'm out of possibilities here. So I can erase this and just declare that this guy over here is a prime polynomial. So this is prime. And so I'm not going to be able to factor this and cancel with anything down here. So this is how I report my answer. 45p squared minus 60p plus 19 over the quantity 3p minus 1 times the quantity p plus 7 times the quantity p minus 1. All right, let's try one that's going to be a little bit tedious overall. And I gave you one that you could simplify in the end. Once you have some practice doing that. So I have 5x minus 5 over x cubed plus 3x squared minus x minus 3 minus 2x plus 7 over x squared plus 4x plus 3. So if you see minus, just put plus and then negative 1. So this negative 1 is going to multiply by the numerator. Remember, if it's a fraction, I don't put negative 1 in the numerator and the denominator because those would cancel. So you just want a negative 1 either in the numerator or the denominator. Preferably, you're going to do it in the numerator. You don't want to mess up your denominator because you need to get a common denominator. You don't want to mess with that. So just put plus and then negative 1 times your numerator, and then you can forget about the messy subtraction. All right, so for my denominator, in this one, I can use factoring by grouping. Right, I have a 4-term polynomial. From the first group, I could pull out an x squared, and that would leave me with x plus 3. In the second group, I could pull out a negative 1, and that would leave me with x plus 3. If I factored out the common binomial factor of x plus 3, this guy would factor into what? You'd have the quantity x plus 3 times the quantity x squared minus 1. Now, x squared minus 1, you might not notice this, but that's what? That's the difference of two squares. So this can be further factored. So really, this is x plus 3 times the quantity x plus 1 times the quantity x minus 1. Always look for further factoring. This is something I see on tests all the time where you get x squared minus 1 just left like this, and the student just kind of moves on. So let's just erase all of this, and we'll bring this up here. So this is our factored denominator. Now to factor this denominator, I'm going to set this up as the product of two binomials. I'll put x here and x here. And then I want two integers whose sum is 4 and whose product is 3. So we know that would be plus 3 and plus 1. Now, I have over here x plus 3 and x plus 1. So those are common to each. So really all I'm missing is this x minus 1 here over here. So this guy right here can stay as it is. I can keep 5x minus 5 as it is. And all I really need to do is take this guy right here and multiply the numerator and denominator by what I'm missing, which is x minus 1. So let's put equals. We've got this. I'm going to put plus. First, I'm going to use my distributive property. Negative 1 times 2x is negative 2x. And then negative 1 times 7 is minus 7. So it would be this multiplied by this. What I'm missing, this quantity x minus 1. Okay, so now that I have that set up, this is over my common denominator, which is x plus 3, that quantity, times x plus 1, that quantity, times x minus 1. So again, all I did was I multiplied the numerator here by x minus 1, which I'm doing right there. That's the multiplication. And I multiplied the denominator. Although I didn't show you that, I'm multiplying the denominator by x minus 1 also. If I did that down here, I would have that common denominator that consists of x plus 3, that quantity, times x plus 1, that quantity, times the quantity x minus 1. So that's where I got that. All right, so now that we fully understand, let's kind of scroll down and let's complete this process. So we've got 5x minus 5, and then plus, we want to use FOIL here. So negative 2x times x is negative 2x squared. Then negative 2x times negative 1 is positive 2x. Then negative 7 times x is minus 7x. Then negative 7 times negative 1 is plus 7. So let me write this over that common denominator. We've got the quantity x plus 3 times the quantity x plus 1 times the quantity x minus 1. All right. In the numerator, I've got my leading term of negative 2x squared. Nothing to combine with that. I've got 5x, 2x, and negative 7x. 5x plus 2x is 7x. 7x minus 7x is 0. Then I'm just left with negative 5 plus 7, which is positive 2. So this is over. We've got the quantity x plus 3 times the quantity x plus 1 times the quantity x minus 1. And I promised you that we could finally cancel something. So in the numerator, if you look, if I were to pull out a negative 2, what would that leave me? I would have negative 2 times, in parentheses, I'd be left with x squared. The sign here would change, so it would be minus, and then if I pulled out a 2, it would be 1. Now remember, x squared minus 1, that's the difference of two squares. So I can further factor that into the quantity x plus 1 times the quantity x minus 1. And this is over. So we'll have the quantity x plus 3 times the quantity x plus 1 times the quantity x minus 1. So look at what we can cancel. We can cancel this x plus 1 with this x plus 1, and this x minus 1 with this x minus 1. And in the end, I'm left with a negative 2 over the quantity x plus 3. You don't need to put parentheses around it. You can just leave it as it is. So this is going to be my simplified answer.